This video we're going to do some example problems from section 10.4. These first two are asking us to simplify quotients. So we will split those up. Here we'll have the square root of 49 over the square root of x to the fourth. Square root of 49 is 7. Square root of x to the fourth. X to the fourth is x squared times x squared. So its square root is x squared. And that is our answer. And this other one, we're taking the third root. And again, we'll split them up, numerator and denominator. Now in the numerator, we're going to have to do some work to get perfect cubes out of here. So what perfect cubes do we have? Well, we have 27 times 2 is 54. And m to the fourth is m cubed times m. M cubed is a perfect cube. So we'll write it separately. Those should be n cubes. Sorry about that. Okay, so the cube root of the numerator, the cube root of 27 is 3. The cube root of m cubed is m. And that leaves under our radical sign 2m. And in the denominator, the cube root of n cubed is n. These we're asked to simplify, but these, if you'll notice, they're already split up into quotient, into a radical expression on the top and a radical expression on the bottom. And these are going to be easier to simplify if we put them together and simplify the radicand itself when we put them together. So instead of having two separate radicals, we'll put this together as 48 over 3. Now 48 divided by 3 is 16. So we have the square root of 16. And the square root of 16 is 4. So that simplifies to 4, and that's something that we would have had a harder time doing if we had left them like that. It would have still worked, but it would have been harder. Okay. This one, we're going to see we have cube root, and this 2 is not under any radical sign. Okay, so we got to keep that in mind. It's hanging out in the denominator. So what I'm going to do is I'm going to pull it out and call it 1/2 and let it just sit out here while we simplify what is inside the cube root. And that is 24 x to the fourth y to the fifth over 3x. So we can now use our skills with simplifying things using the laws of exponents, and we'll end up with 1/2 times the cube root. 27 divided by 3 gives us 8 on the top. X to the fourth divided by x gives us x cubed. And y to the fifth is just y to the fifth. And there's nothing on the bottom anymore. So now we can write this as the cube root of 8, which is a perfect cube. It's 2 cubed. X cubed, which is a perfect cube. And y cubed, y squared. Y cubed is a perfect cube, y squared is not. And we can put that 2 back in the denominator where it's not going to bother us anymore. Okay, I'm going to come up here. So the cube root of 8 is 2. The cube root of x is x. The cube root of x cubed is x, sorry. The cube root of y cubed is y. And we still have that cube root of y squared in there. And in the bottom we have 2. The 2's will cancel out and we are left with x, y, times the cube root of y squared. A little bit more complicated. These ask us to rationalize the denominator. So basically what we want to do is we want to get rid of the denominator. In this first one, if we multiplied the bottom by 7, we would have a perfect square because we would have 7 squared. And we can do that inside the radical, just multiply it by 1. If you multiply anything by 1, you do not change the value. You create an equivalent expression. It's going to look different, but it's equivalent. And so we are choosing 7/7 as our form of 1 because that's what gives us a perfect square on the bottom. That'll give us the square root of 35 over 49, which is the square root of 35 over 7. Final check, you want to look in that denominator and make sure there are no radical expressions in that denominator. Here, it's a little more complicated what we might want to do under the radical, but we want to create a perfect cube out of this 25. Well, 5 cubed is 125, so if we multiply by 5 over 5 under that radical, then we will get the cube root of 15 over 125. And if we go ahead and separate that out, we get the cube root of 15 over the cube root of 125, which is 5. There are no perfect cubes in 15, so we have to leave that like it is. Okay, more rationalizing the denominator. So I'm going to do these the other way, which is multiplying outside of the radical. And it really is simply preference by what you do. But I want to make 3x, the square root of 3x, I want to multiply it by the same thing so I get a perfect square, right? So if I multiply the denominator by 3x, and this works with squares always. If you just multiply by what's there, you're going to end up with a perfect square. You'll just end up with the radicand is what you will end up with. So that's a good way to do it when you have perfect squares. Okay? So again, I have to multiply by 1 so that my new expression is equivalent, but I want to multiply by the most convenient form of 1. In this case, it's root 3x over root 3x. Root 5 times root 3x gives us root 15x. And root 3x times root 3x, like I said, gives us just the radicand, 3x. So that denominator is rationalized. Now this one's a little more complicated. We have to multiply outside of the radical because we have to multiply both numerator and denominator, and they're not both under a radical sign. So we have to multiply by whatever is going to end up giving us perfect cubes. Okay? So we'll multiply by the cube root of what makes 4 into a perfect cube? Well, if we multiply it by 2, we'll get 8, which is 2 cubed. That should have been a 2. If we multiply it by 2, we will get 8 and make it a perfect cube. Okay, so we'll multiply by 2. X is not a perfect cube, but x cubed is a perfect cube. So if we multiply by x squared, we'll end up with x cubed, and that will be a perfect cube. Y squared is not a perfect cube, but y cubed is, so if we multiply by y, we'll end up with y cubed. And what we do on the bottom, we must do on the top because we can only multiply by 1 without changing the value of the expression. So now on the top we have 3y times the cube root of 2x squared y. No simplification you can do with that because there are no perfect cubes in that. But on the bottom, we end up with the cube root of 4 times 2 is 8. X times x squared is x cubed. And y squared times y is y cubed. And now we'll go ahead and take that cube root. So again, our numerator cannot change because there are no perfect cubes in here. And our denominator becomes cube root of 8 is 2. Cube root of x cubed is x. Cube root of y cubed is y. Now, we see that there's a y on top and a y on the bottom. So those can cancel each other out. Our final answer, I'm going to squeeze it in over here, is going to be 3 times the cube root of 2x squared y over 2x.